Hello, my dear students, and welcome back. With your exams just around the corner, I know you're all studying so hard. So today, we're going to do a super quick and super easy revision of a very important chapter, data communication. We're going to uncover the secret adventure your messages take every single time you hit send. It's a journey that happens in less than a second. I mean, think about it. You type a message to your friend, maybe share a funny Instagram reel or a YouTube short, you press that little paper plane icon, and poof, it's gone. But where does it go? How does it travel all the way to your friend's phone, maybe miles away, in just a second? It feels like magic, doesn't it? But it's pure technology. And today, we're going to break down this magic piece by piece. So, just like the slide says, Cholo, let's find out. You see, for any communication to happen, we need a team of 5 heroes working together. Think of them like the Avengers of the internet world, right? Each with a special job to do. So let's meet them one by one. First up, we have the sender. This one's easy. It's the device that starts it all. When you send that message, your phone is the sender. Simple, right? It's the starting point of our message's big journey.
Next, of course, if you have a sender, you need a receiver. This is the destination. It's your friend's phone eagerly waiting to get your message so they can reply with a laughing emoji. So, to put it simply, the sender starts the conversation and the receiver gets it.
Our third hero is the message itself. This is the actual what you're sending. It could be a good morning text, a funny sticker, a photo of your notes, or even a video. All of this is data. Now, how does the message get from the sender to the receiver? It needs a path, a road to travel on. This road is our fourth hero, the transmission medium. This can be a physical wire, or it can be invisible waves in the air, like your Wi-Fi. And finally, our fifth and maybe the most important hero, the protocol. Imagine lakhs and lakhs of messages traveling on the internet road at the same time. It would be total chaos. The protocol, well, they're the traffic rules. Without them, the internet would be a massive traffic jam, and your message would probably get lost. They keep everything orderly and make sure your message reaches its destination safely. So, our team of 5 heroes is ready. Now, just like our real roads can be a one-way street or a huge highway, the paths for our data can also be different. Let's look at the 3 main types of traffic flow for our messages. As you can see, there are 3 main types. First, we have simplex, which is like a one-way street. Data only flows in one direction, like from your TV remote to the TV. The TV doesn't send anything back, right? Next is half-duplex. Think of this as a narrow bridge where only one car can pass at a time. A walkie-talkie is the perfect example. You talk, then you listen. You can't do both at once. And finally, the one we use all the time is full duplex. This is a proper 2-way highway. Data flows in both directions at the same time, which is why you can talk and see your friend during a video call. Now, listen to me very carefully, Beta. This is an extremely important topic for your exams. The difference between these 3 is a pukka, 100% guaranteed 3-mark question, so make sure you understand these examples perfectly, okay? So how does the internet manage all this traffic? Well, in the old days of landline phones, they used something called circuit switching. A dedicated line, a private road was created just for your call. But the modern internet uses packet switching. Your message gets broken down into tiny parcels called packets. Each packet is sent out on its own and might even take a different route, like little delivery boys finding the fastest way. At the destination, they're all reassembled. It's so much more efficient. If one road is blocked, the packets just find another way. Okay, so we know our message packets are smart enough to find the best route. But what are these routes, these highways of the internet actually made of? Well, they come in 2 main types, physical wires you can touch and invisible wireless waves. So let's explore these 2. First, we have guided media, or what we simply call wired connections. This is a physical cable connecting one device to another, providing a fixed path. Then there's unguided media, or wireless, which sends data right through the air using invisible waves, like your Wi-Fi or your mobile data. For wired connections, there are 3 main cable types. Twisted pair is the cheapest, like in our old telephone lines, but it's slow and gets easily disturbed. Coaxial cable, which you see for your TV connection, is a bit better. And then there's the superstar, optical fiber. It's made of glass, sends data as light, is incredibly fast, and has no interference. It's expensive, yes, but it is the future. And in the wireless world, we have different types of waves. Radio waves bring you your favorite FM radio stations. Microwaves are used for things like satellite TV. And infrared waves are what your TV remote uses to change the channel. See, it's all around us. All right, let's talk about something you all know very, very well: your mobile data. From 1G to 5G, our internet speed has gone from a bullet cart to a supersonic jet. Let's see how. Back in the 80s, 1G phones could only make calls using analog signals. With 2G in the 90s, we went digital and got the magic of SMS. 3G brought basic internet to our phones, which felt amazing at the time. Then came 4G, which changed everything and let us stream HD videos without all that buffering. And now 5G is here. It's not just about faster downloads. It's about connecting everything to the internet, from self-driving cars to smart homes. The speed needs to be incredible for that to work. All right, let's do a quick revision round to lock in these concepts for the exam. Ready? First question. What exactly is bandwidth? Pause for a moment and think about it. Did you get it? Bandwidth is simply the width of our data highway. So a wider highway, or higher bandwidth, means more data cars can travel at the same time, which means faster speed. So the crucial point is, more bandwidth equals faster internet.
Okay, last question. You see HTTP at the beginning of almost every website address. What does it stand for? Give it a thought.
It stands for Hypertext Transfer Protocol. This is the main traffic rulebook, the main protocol that our web browsers and web servers use to talk to each other. It's the foundational rule that makes the entire World Wide Web work. And that's it. We've covered the entire journey of your message in just a few minutes. I know you are all working very hard, and you're going to do wonderfully. Don't be nervous. You've got this. Now go and ace that exam. All the very best, my dear students.